In this slideshow, I will explain what do you mean by ions? What are the ions? Let's move to the next slide. When atoms or molecule gain or lose electrons, they become ions. When the atom or molecule lose electrons, it becomes positively charged. Positively charged ions are called cations. When the atom or molecule gain the electrons, it becomes negatively charged. Negatively charged ions are called anions. Let's move to the next slide. Let's look at how cations are created. First, aluminum-27, which is atoms. How many protons, electrons, and neutrons are in aluminum-27? Because aluminum-27 has atomic number of 13, aluminum-27 should have 13 protons. And remember, in an atom, there is always same number of electrons as protons. Aluminum-27 atom, there are 13 electrons. The number of neutrons is equal to the mass number minus number of protons. Therefore, 14 neutrons. Because aluminum-27 atom has 13 protons, and each proton carries +1 charge, total you have positive 13 in aluminum atom. There are 13 electrons in aluminum-27 because each electron carries -1 charge. 13 electron will give -13. Therefore, positive 13 and negative 13 cancels out, and atom is always neutral object. Let's look at the cations. Aluminum 3+. 3+ in a right-hand subscript indicates that atom loses 3 electrons. When aluminum atom loses 3 electrons, how many protons, electrons, and neutrons are in the atoms? Number of protons doesn't change because aluminum atom did not lose protons. 13 protons still there. Because aluminum atom lost 3 electrons, now you have only 10 electrons. Neutrons are not lost. It's still 14 neutrons. Now, 13 proton will give positive 13. However, 10 electrons only gives -10. Therefore, positive 13 plus negative 13 gives positive 3. That's how, by losing the electrons, atom becomes cations, which is positively charged ion. Let's move to the next slide. Now let's take a look how anions are created. Selenium-78, how many protons, electrons, and neutrons present? There are 34 protons, same number of electrons, 34. Neutrons number is equal to mass number minus number of protons, which is 44. Again, because you have a same number of electrons and protons in atoms, the atom is neutral object. Now let's look at the selenium 2-. The right-hand superscript 2- indicate the atom gains 2 electrons. 2 minus means gain the 2 electrons. Therefore, in this atom now, after gaining 2 electrons, 36 electrons are present. 36 present will gives negative 36. The number of protons did not change. Therefore, still it's positive 34. Positive 34 plus negative 36 is negative 2. This is how, by gaining the electrons, atom becomes negatively charged object, which is called anions. Let's move to the next slide. So remember, the superscript, right-hand superscript, positive means loses electrons, and negative means gaining the electrons. In the beginning, this is very hard to associate positive with lost and negative with gain, because typically we think about positive is gain and the negative is lose. That's how we associate positive and negative. But in chemistry, when you see the positive in a superscript, that means you lost the electrons. And when you see the negatives in a superscript, that means you gain the electrons. It is really important that you understand this. Let's move to the next slide. Now I will explain what is a monoatomic ions. Let's move to the next slide. You can make the ions from atoms or molecules. When the atom loses or gains electrons, it becomes monoatomic anions or monoatomic cations. So this is in a table. Table is showing the example of monoatomic anions or and cations. Let's move to the next slide. The number of electrons lost or gained is related to position of periodic tables. For example, group 1A, all the elements in a group 1A except hydrogens always loses 1 electron. The same number of electrons is lost as group number. First of all, remember if the element is metals, they always, or not always, but they tend to most often lose electrons. They do not gain the electrons. In other words, metal becomes cations. So therefore, group 1A elements loses 1 electrons, becomes positive ion. Group 2A loses 2 electrons, becomes 2 positive ion. Group 3A metals loses 3 electrons, becomes 3 positive ion, cation. Let's move to the next slide. Now, non-metal atoms, they often gain electrons. They usually do not lose electrons. Therefore, non-metals tend to become anions. Again, number of electron gain is related to the position of periodic tables. Let's look at this example. Group 5A. The elements in a group 5A always gain 3 electrons and becomes 3 minus ion. Group 6A becomes 2 minus ion by gaining 2 electrons. Group 7A becomes negative ion, negative 1 ion by gaining 1 electron. How about group 8A? Well, group 8A elements, they never lose or gain electrons. So they are very inactive element. So here, how do you remember this? What is a relationship with the numbers of electron gained to the position of the periodic table? This is how you can think about this. Group 5A gain 3 electrons. 5 plus 3 equal to 8. Group 6A gain 2 electrons. 6 plus 2, 8 electrons. Group 7A gains 1 electron. 7 plus 1 is equal to 8. So 8 is more or less like magic number. And that's how you can remember how many electrons are gained by the non-metal atoms. Let's move to the next slide. There's one exception. Hydrogen. Hydrogen can lose or gain the electrons. They can become hydrogen plus or they can become hydrogen minus. Let's move to the next slide. So what are the names of the ions? Well, when you make the cations from atoms, the name of the cations are the same as the name of the element. For example, sodium plus, that's the cations. What is the name of sodium plus? The name would be sodium ion. It is the same as the name of the atoms, except you have to say sodium ions. It is not sodium atom. However, anions, you need to change the name. Monoatomic anions use the ending "ide." For example, O2 minus, the oxygens, becomes anions. You cannot say oxygen ion here. You have to say oxide. And the name of the ion need to end with "ide." Let's move to the next slide. The elements in transition metals, and also some exceptions such as tin and lead, they can form more than one type of cations with different charges. For example, let's look at the chromiums. Chromium atom can form chromium 2 plus, chromium 3 plus, chromium 4 plus, and chromium 6 plus. So the chromium atom can form any of these 4 different cations. Therefore, to specify the identity of these ions, you need to use Roman numerals in parentheses to equal to the charge. So for example, chromium 2 plus is, the name is chromium, parentheses 2, parentheses ion. Chromium 3 plus is chromium, parentheses 3, and parentheses. This does not happen, for example, for the sodium ions. You do not say sodium, parentheses 1, and parentheses. Because sodium becomes ion, they always lose 1 electron and become sodium plus. Therefore, you do not have to specify the charge with a Roman numeral. This only happens in elements in transition metals and tin and lead. Let's move to the next slide. Now I'd like to explain polyatomic ions. Remember, molecule can gain or lose electrons, and they become ions. Let's move to the next slide. It is important to know the formula, charges, and names of polyatomic ions. Polyatomic ion is basically, it is ions made from molecules. Let's move to the next slide. So I will explain the idea of polyatomic ions. Let's go back and look at the molecule. For example, CO2. CO2 is called carbon dioxide. It is a molecule. How many number of protons in this molecule? It is 22 protons. 6 protons from 1 carbon and 16 protons from 2 oxygens. So total, there are 22 protons. And because each proton carries positive 1 charge, 22 protons give positive 22. How about total number of electrons in this molecule? 6 electrons from 1 carbon and 16 electrons from 2 oxygens. Total 22 electrons. Because each electron carries minus 1 charge, 22 electron gives negative 22. So positive 22 and negative 22 again cancels out, and a molecule is, just like atoms, neutral object. There is no electrons gained or lost in molecules. Let's move to the next slide. NO3- is a polyatomic ions. Why? Because you see the superscript negative. Negative means negative 1. That indicates there are 1 extra electrons in this molecule. How many number of protons in these ions? 7 from 1 nitrogen and 24 from 3 oxygen. 31 protons. How many electrons in this ion? 7 from 1 nitrogen and 24 from 3 oxygens. And here is very important, you have 1 additional electrons because the chemical symbol says it's negative. Negative means minus 1. That indicates you have 1 additional electron. Total, there are 32 electrons in this polyatomic ion. Therefore, positive 31 and negative 32 becomes negative 1. Therefore, this polyatomic anion is negatively charged object because of 1 extra electron. Let's move to the next slide. This is a common mistake. Students often ask this question, so I want to clarify this. First of all, SO3. What is the name of this SO3? It would be sulfur trioxide, and that's okay. SO3 is a molecule, so you would say sulfur trioxide. Then, what is the name of SO3 2-? Can you say sulfur trioxide ion? No, you cannot. The name of this polyatomic ion is sulfide. It's not related to the name sulfur trioxide. It's simply sulfide ion. And the reason is the SO3 2- is ion, and SO3 is a molecule. And the molecule and ion have different naming schemes. Let's move to the next slide. So, at this point, you should understand all 3 different objects: atoms, molecules, and ions. And ions is the most complex object because ion has different kinds. Ion has monoatomic ions. Monoatomic ion is, remember, it's made from atoms. Polyatomic ions, made from molecules. And each ion can be positive or negative. So make sure you understand all these 3 different objects, atoms, molecules, and ions, and you should know the differences between them. This is the end of the part 1 slideshow.